We've got to expand a plus b to the power 6 here, right? So Pascal's triangle, right, all the way to, so we've got expansion to the power 6. So when you see 6, then it's the second number, and that's the row that we need. So we've got then a plus b to the power 6. Remember then, when you expand them for the binomial theorem, always start off then with a to that highest power. Okay, using these coefficients then. So the first coefficient was 1, second coefficient then is 6. And then a, then reduce the a, so a to the 6 there, so it'll be a to the 5 here, and then start increasing the b's. So it's b to the 0 there, which we don't write, so b to the 1 here. Next coefficient is 15. So a to the 4 then, reducing the a's, increasing the b's. B squared. 20 then, a cubed here, okay, decreasing the a's, increasing the b's. 15 then, reducing the a's, increasing the b's. 6 then, coefficient, reducing the a's, increasing the b's, and then at the end then b to the power 6. Okay, so there's my expansion there. Part B then, it says find the value of the term independent of x in the expansion of x squared plus 2 over x. Now of course it's the power 6, so we can use this here, yeah, where my x becomes, my a becomes x squared, my b becomes 2 over x. Okay, so we want to find the value of the term, as it says, independent of x. So in other words, x isn't involved. Okay, so we don't need to work out every term here. Okay, you know, for instance, the first one here, well, a becomes x squared, doesn't it? So this will be x squared for a, but then you've got to raise it to the power 6. Now clearly I think it's going to be x to the power 12, isn't it? That's got x in it, isn't it? It's dependent on x, so we don't need that. Okay, and you can go through them to find out which one will be independent of x. So you know, when we look at the next one, we've got 6a there, which is x squared to the power 5. Okay, and then b then, which is 2 over x. Now clearly when you simplify that, that's going to have an x there, yeah, because you're going to have x to the power 10 there on the top, divide by x, that's x to the power 9. It's not going to be independent of x, so that's no good. So we can keep going. So go for the next one, a to the power 4, so that'll be x squared to the power 4. Again, that's going to produce x to the power 8, so that's no good. And you've got b squared then, so that's only going to make that an x squared. So you have x to the power 8 on the top, x squared on the bottom. No good, right? So we keep going. The next one then, we'll have, let's write it underneath. We've got 20 a cubed, so that'll be x squared all cubed. And then on the bottom, on the b then, will be 2 over x cubed. So that's x to the power 6 here. And that's going to be x to the power 3 on the bottom. That won't be independent of x. We've got to keep going. The next one then, 15 a squared, so it'll be x squared all squared times then b to the power 4, which will be 2 over x to the power 4. Now this is looking likely, isn't it? This is looking a good candidate, because if you notice here, right, this simplifies x squared to the power 2. Well, you multiply those powers, so that'll be x to the power 4. Okay, when you multiply those powers there, and then 2 over x to the power 4 becomes, well, you apply the power 4 there, so 2 to the power 4 is 16, x to the power 4 is just that, and you notice then that the x to the power 4, x to the power 4's cancel, so this will be the one that's independent of x. Okay, there's no x involved, so you just got 15 times 16, which is 240. Okay, so that will be the term that's independent of x. You can check the remaining two as well, but you'll see there'll be an x involved there. Okay.